This video, we're going to cover chapter 13. Before we go on to chapter 13, let's do a quick review question. So if you have a black and rough fur, and this is a dominant trait, so this particular question is now getting into two trait question, which is new. Okay, so the idea is, can you do one of these two trait questions? Let's practice. Two trait question says, the fur of a bear can be either black or brown, rough or smooth. And black and rough are dominant. So let's build our key. Black is big B, or big B, little b. That means brown will be what? Little b, little b. What about rough? Rough will be big R, or big R, little r, while smooth will be little r. Once you have your key, then you can start listing your genotype. So it says a heterozygous black with smooth fur bear. Black, heterozygous. That means which one? Yes, big B, small b. With smooth fur. Smooth is what? Little r. And a brown, so it crosses with a brown smooth fur. Brown, small b. Smooth fur, that means little r. Now, these two bear crosses and they have cubs, so little bears. Now, the question is, what is the phenotypic ratio of their cubs? Let's do this. So number one, you list out the genotype. Number two, you figure out what? The gametes. So what type of gametes would this particular bear make? Let's think through. Law of segregation says allele of the same gene separates. Law of independent assortment says different trait, fur color, or roughness is inherited independently. That means I can be little r or big R, but in this case, there's only little r. So I only generate these two. What about this individual? What kind of gametes does it generate? Well, there's only one kind. Now that you have your gametes, can you do the cross? Yes, let's do our cross. Oops, I probably don't need this. So let's generate the cross. Okay, so big B, little r, little b, little r. So what is your phenotypic ratio? Don't forget, you need to translate this back into phenotype. What is this? Oh, it's black. And what is this? Oh, it's smooth. What is this? Oh, it's brown. What is this? Oh, it's smooth. So what's your result? Your phenotypic ratio will be black and smooth to brown and smooth equal 1 to 1. Okay. Next question. Going to erase all of it. Let's do the blood type. A blood type O. Recall, how do you set up the genotype? Blood type O is little I. Had a blood type A daughter. Okay, so this is a dad. He and mom had a daughter, and she is blood type A. What could be mom's genotype? Let's think through this. Dad can only give little I, and the daughter is A, so the other allele must be what? Big IA. So what is mom's genotype? Well, I know for a fact that mom needs to then give this one because daddy gave the little I. So mom can be big IA and whatever we like. because as long as she has a big IA, she can give rise to a daughter. So what can we put? We can put big IA, big IA. We can put big IA, big IB, and we can put big I, little I. Okay, so this is just kind of a review of what you should have gotten up until this point. Okay, and then we're going to do much more questions coming up, because that's mainly what we're going to cover on the exam. So in this chapter, we're going to really drive home the fact that your chromosome is where the gene lives. Okay, so these chromosomes are made of DNA. Recall what we talked about previously. And on those DNA is coding of a gene. Human have how many chromosomes total? 46. Out of them, 22 are what we call autosome. So if you have one chromosome 1 from mom, you similarly have one chromosome 1 from dad. You have one chromosome 2 from mom, you have one chromosome 2 from dad. And you got 22 pairs of this. I'm going to jump forward so you can see. Here's your view. You have 2 chromosome 1, 2 chromosome 2, 2 chromosome 3, 2 chromosome 4, and 2 chromosome. But in the end, there's something interesting. You have something called the sex chromosome. So you got 22 pairs of autosomes, but you got one pair of what we call sex chromosome that determines your sex. You can have 2 X chromosomes, then you are a girl. Or you can have 1 X and 1 Y, then you are a boy. Okay? And there's something interesting about genes that sit on this sex chromosome, because due to the fact that it sits on your X chromosome, then it will be inherited in an interesting pattern. So let's cover this last part on how genes that sits on your X chromosome is inherited. We call these genes sex-linked, and usually we mainly talked about the X-linked one. The main reason is Y chromosome is only in male. So as long as you have a gene that's on Y, a gene that's on the Y chromosome, then it always affects male, right? Because female doesn't have it, and males is always going to show it because it has the Y chromosome. So whenever we talked about sex-linked, usually we're talking about X-linked. And in all the exam questions, it will be X-linked recessive trait. There's 2. One is color blindness and one is hemophilia. Color blindness is a trait where this individual cannot distinguish between red or green. To them, it looks similar. Hemophilia is a condition where the affected individual has blood clot problem. And this is very important, because if your blood cannot clot, then it'll keep bleeding, especially if you have internal bleeding. That will be very hard to detect, and it could lead to very serious problem. So hemophilia is a disease that affects a single protein. So it's not polygenic, it's just one gene, and once you have it, then if you have both allele affected, then you will have what's called hemophilia. The interesting thing is this blood clotting problem, just like the color blindness, is inherited kind of differently in male and female, mainly because the fact that it sits on the X chromosome. So think of it. For girls, you need both of them affected to have hemophilia. If you have one that is okay, big H, and one that is affected, you are normal. But what about boys? Boys is 1 X and 1 Y. So for boys, if they just have one, then they are affected. And this is why a lot of X-linked traits are unproportionally presented in male, because if they're hit with one allele and they just inherit that one, then they don't have the other one to balance it out, and they have the trait. Okay, so moving forward, we're going to do quite some problem solving, needing you to have the understanding that the gene sits on a chromosome, and all autosomes are in pairs. You one from dad, one from mom, one from dad, one from mom. But sex chromosome isn't the same. For girls, there are a pair, but for guys, you only have one X, and that determines your fate. If your gene sits on that X chromosome and you inherited the recessive form, then you will show the trait because you don't have the other one to balance it out. Okay, so we're going to move forward and really talk more about how this affects a trait's inheritance. Mainly, I'm going to add one more thing you'll need to think about. We've already set up a formula that first you list the genotype. Second, you ask what's the gametes. 3, you cross them. 4, you interpret and say what is the phenotype from the genotype. Now, to solve many of the genetic problem moving forward, you have to ask 2 questions. Okay. 1, is the gene sex linked? Oops. Let's go back. Okay. You're going to ask, is it sex linked or is it autosome? That's your first question. Second, you're going to ask, is it dominant or is it recessive? And once you have answer to this, then you can begin to build your genotype, okay? Then you can begin to build your number 1, which is what is the genotype. So we'll move on to this very shortly in our worksheet, okay? The very last part, we already kind of covered this, and this just means the very last part regarding inheritance. Sometimes when the gametes are separating, you're supposed to separate the 2 gametes, or sorry, in this case, let's use the sex chromosome, XX. You're supposed to separate them. But sometimes nondisjunction happens and they don't separate. And you got one egg with 2 X's and the other egg without any. In this case, you said nondisjunction happened, failure of homologous or sister chromatids separate, and you can lead to something called aneuploidy. That means you gain or lost a chromosome. If you have lost it, then, for example, this egg matched with a Y chromosome will lead to XXY. This without any sex chromosome will lead to only Y. And when you just have one for the pair, then you're called monosomy. If you have gained something, then you're called trisomy, because now you have 1, 2, 3 as opposed to 1, when every single time you should have a pair, 2 of everything. In most of the cases, nondisjunction doesn't result in viable zygotes, and then you will have something called miscarriages. Because how chromosomes are labeled is from big to small. So usually these type of big ones that carry a lot of genes, it's very hard to survive when you have an extra set. What's known that can survive are extra copies of chromosome 13, 15, 18, 21, 22. The most known one is called Down syndrome, which is trisomy 21. That these individuals actually have 3 chromosome 21, and this occurred most likely during meiosis in forming eggs or sperm, that 2 of them came into one gamete and met the other one, and now you have 1, 2, 3, as opposed to a pair of everything else, okay? What's interesting is this can also happen in sex chromosomes. And in sex chromosome, when this happens, you can result in several kind of syndromes. So let's look at this. if a girl who has XX, it should originally separate into 1X and 1X, but it failed to separate. Now you have 2X's coming into an egg, and the other one doesn't have any. Then when this egg meets the sperm, you can end with something called XXX, which is a triple X syndrome. You can end with something called XXY, which is Klinefelter syndrome. Or you can end with a situation where you only have one X called Turner syndrome. Any individual requires one X chromosome to survive. So to have only one Y chromosome is not viable because you got essential genes on your X chromosome. Okay, with that, we're going to move on to some worksheet problems. And let's see how we can now utilize what we've taught here to help you solve some interesting genetic problems.